Okay, and welcome back. This is Microsoft Virtual Academy. This is the Jumpstart for C# exam 70384.
438.
438. Well, 359. 483.
It's been a long day and it's just got longer. Let's start that again.
All right, here we go. Module 7. Module 7, specifically, we'll be talking about some interesting things, Darren. What will we be talking about?
We'll be talking about how to interact with the file system. And yes, we have touched on that very lightly earlier on, but this is going to be a much deeper dive into those areas.
Yeah.
And then we're also going to be talking about working with REST services.
Yeah, and just web services in general. I mean, it's a reality that service-based architecture is everywhere, and knowing how to interact with it properly, knowing what your options are, and the.
So did you just make up another term there?
Which
SBA
one?
Instead of SOA?
What's SBA?
You said service-based. Service-based
architecture.
Jerry World.
Service-oriented architecture.
Awesome.
Based on services.
Okay, let's move in.
Okay, let's get started. All right, reading and writing. So we can read and write from the file system. We will just assert that at the beginning, but let me just ask, why in the world would we read or write from the file system? We have memory that we can interact with, and allow me.
It's basic persistence. I mean, ultimately, you've got memory, but that's volatile. That requires the system to be powered. That requires that you have available memory to store things. As you create more and more information, you may overflow your available memory space. So you need somewhere to be able to put that out. Many traditional systems would use the file system as an intermediate store for that data.
So it's a way of taking data out of memory and putting it down into the file system so that we could, there's a lot of good reasons for that. Not only to save memory, but also to be able to cross certain boundaries. Session boundary, so the next time you run your application, it's still there. Whatever you put in memory would be lost. I can also cross other boundary. I could say to a share, out to SharePoint, something like that, and it would go from user to user as well.
So you're crossing machine boundaries as well as user boundaries?
I could save out to a network share that way. Another reason I might use it is because the user is giving me something. I'm interacting with the user. Let's say Photoshop is an interesting example. Let's make it black and white. What do you want me to make black and white? They give me an image. Okay. So I need to be able to read from the file system in order to accept data that the user gives me. Another one might be because I need to sniff out the environment, and kind of figure out the configuration of that environment. Do they have this folder? Do they already have the file? Do they have a previous session XML file sitting there?
Okay, so it's almost session persistence as well. So you can go in, say, have I already been here, read in those values, any default settings, and so on.
Yeah, and so like we would expect, the framework has given us a lot of value back. They have given us a lot of methods and ways to interact with the file system that are very simple. Reading and writing is just a breeze. It's almost as easy as your decrypt and encrypt.
Yeah, almost.
All you have to do is find, almost. It's almost. And and there are different things I can do. So I could open a file, and of course we saw that before where it locks that file, right, for reading. And I could open it and directly read it and close it again, right? So here we can see in the slide, write all text, read all text. That's an open-close, kind of an open-shut kind of operation. It happens, it opens it, it locks it, it reads it, it closes it, and it's unlocked. Right?
Awesome. So it kind of encapsulates an atomic operation.
It does. I mean, honestly, it saves you quite a bit of code that you could have done without it, but that's quite a mess. And so it's nice just to have these helper methods to do it for you. Another thing we can do, and this is special not just for file reading, but also talking to services, is to interact with a stream. You could have a very, very large file. So for example, the user could point me to a file that I need to read. It's an XML file, and it's a 5 GB file. I can't go take that and put it up in memory and then start operating with it.
So another example of that would be something like Netflix, where you have a very large encoded video that's sitting out on a server. You're not downloading that entire movie before you play it. You're actually streaming it across chunk to chunk. That's right.
Streams are important because it allows me to operate on it in smaller portions. Of course, it has to be formatted in such a way that I can do that. But it prevents for one, just waiting. A movie's a great example. You don't want to wait the 20 minutes or 10 minutes or whatever it would take to download the entire movie before you start to watch.
And this actually ties into a question that we had earlier on around unencrypting streams. If you think about movies, movies are all encrypted. They have digital rights management embedded into them, so you cannot just download any old movie and play it. Anything that's streaming across from Netflix or whatever is encrypted, and so that's being encrypted on the fly, chunk by chunk, before it's being played.
Let's take a look at this simple sample. This simple sample is just being able to write all the content into a file. So here we can do something that is it's mine. That's all right. So the
Barry thought that was Visual Studio.
Yeah, that's all right. It looked like it. The first thing that's nice is that I can start fetching directories, right? I can ask for things and not have to figure them out. Asking what my current directory is certainly valuable, but others that we'll talk about in a minute. But it's nice to have that. Again, it's the framework giving you so much. The file, then we'll create, you did this in your demo as well, right? Using the path object to be able to combine, it returns back a valid path. I mean, we could do the same thing by saying, you know, directory plus slash plus file name, right? But you don't have to fiddle around with that, and you don't have to worry about invalid characters that may cause that path not to work. This fixes all of that for you.
And the other thing as well is that although we generally consider C# and the .NET environment running inside the Windows platform, it actually is multi-platform. There's Mono, which is an implementation of .NET. You have it. Silverlight runs on the Mac platform and so on.
Right.
And so things like path.combine and environment.newline, they will return the correct path structure for the system on which it's running.
Yeah, if you were to reflect into those and look at how they're implemented, they certainly are not just directory plus slash plus file name, right?
Exactly.
They're doing real work behind the scenes. Okay, let's look at just the write. The write's easy enough. The write is system.io.file is that namespace where it's all put for me. And then there's a static method I can call write all text. This is certainly the simplest way you could possibly write to a file. And so here it is. I pass the file. The file is just the path to it. And then I pass the content. And so in this case, it's how now, brown cow. How now, brown cow. And so I pass that as the content, and it's done. I don't have to worry about using a using statement wrap to make sure I close it. This does it all for me. And to read it, there's a converse method that allows the same simple operation. This time it's returning the content of a file, and I can pass additional parameters to it to how I want it to handle if there is no file there.
Okay, so these show you've got system.io in front of those. If we had a using for system.io, you wouldn't need to do that, would you?
You're right. That would be the shortcut. I could put system.io up into a using, and from that point forward, it's just file dot. Okay. File really is the class that holds all those static methods.
Perfect.
Beautiful. All right, let's jump to the next one and talk about finding the file. So we alluded to the fact that you can get the current directory from the framework, but there's so much more. You know, in Windows puts together its full operating system. So you have temp folders and you have directories that are for your desktop, for your favorites, and it just goes on and on and on. Each one of those you could hunt down by. You. What's that?
Much like you.
Much like me. Going on and on. Yeah, this is not. Let's see. Counting to 10. All right. Okay. But the reality is, being able to find those, you can find most of them by convention. I know that my fonts folder is in my Windows folder, so all I have to do is figure out where Windows is installed. Yep. That's a pain, right? And also kind of unreliable. And so all of those Windows special folders are presented back to the developer so that they can reference them directly and always rely on their value. And so if I want to ask where the Windows folder is, I can immediately get it back and not be worried that it's not right. I also have this thing called isolated storage. I think developers have underutilized something that's really special. And so every .NET application has the opportunity to use isolated storage. Isolated storage is both unique to your application and to the user, and basically it's a dedicated folder structure that you can store anything. Isolated storage, isolated to your app for that user. And what's great about isolated storage is it's kind of hidden away, so you don't have to be worried about the user coming in and tampering with your files. Doesn't mean they can't, but it means they shouldn't. And it also means that Isolated storage is dedicated for you, so you don't have to worry about other applications getting into it. Probably the best part, there is sort of a boundary around it so other apps can't tamper with it, even though the user can come in and kind of
So it's kind of part of the sandbox in which your application runs.
Yeah, it really is. It really is. It's in the profile, under the profile folder, and it's great because it allows you to kind of have your own temp folder or temporary folder structure so that you can throw files in or whatever it is. Anyway, so I can find out where all of the special ones for Windows are. I can find out where my application is. I can even find the isolated storage folders that are for me. And then I can hand code anything I want. This is special, of course, for development that's not Windows 8 development, where there is a caveat. You can't just go anywhere in Windows 8 development. The sandbox has a thicker wall, so to speak, and you can't just go out and do anything.
It's very similar on the phone as well.
Very similar on the phone. Very, very similar on the phone.
Yep.
In fact, it may have the ultimate of all the walls, to be honest.
Exactly.
Having said that, a desktop developer can just say C:/, you just go to it, right? And there is no intermediary broker that says you can't do this because of a type of policy.
NTFS file system security.
That's right. Just like writing to a performance pointer requires certain security and you can't overcome that with code, at the same time, certain folders may have security. You can't overcome that with code either. You have to have the permission to do it.
Yeah, you can't iterate through your Windows installation and delete every file.
Right.
Not unless you've got a very big hammer.
You got that right. All right. So let's take a look just at some of the implementation, just generally. The special folders, this is just a touch. I mean, there are probably 25 special folders inside Windows. Here's an easy way for me to go get the path to my documents, to common application data, which is great. That's a hidden folder that applications can store their data in one place. And that's really a great, another underutilized piece of Windows, without a doubt. Where I can go directly to program files. This is where I would find your application and do some mess to it. And find the desktop. You just go on from there. There's a whole list of them. How I could get the application folder. Often that is important. You may have embedded a file or some sort of data, some sort of resource that you want to access when your application is running, and it came along, it kind of tagged along during installation. And so the current directory is really valuable and a difficult thing just to figure out if it wasn't given to you. That's for sure.
For sure.
And here's the way we would get to isolated storage. And isolated storage has a scope about it. And anyway, we're not going to talk too much about isolated storage, except for to say everybody should use it more. No doubt about it.
Absolutely.
And then manually, this is how we just go grab it. I could go instantiate a new directory info, and directory info is a special class that we would use inside system.io that would give us back the size. It would allow us to iterate through it, when it was created, when it was modified last. It's a great way to get metadata for a directory. No doubt about it. But then there's more to it, right? I don't want to just write to a file. I don't want to just read a file. There's more things I need to do. I might need to move a file or rename a file. Of course, rename and move are really the same operation, right? They're just wrapped together, and we treat them differently, but they're exactly the same, right? When I move a file, I'm actually renaming it. When I rename a file, I'm actually moving it. I guess really they're always moving. Rename is just a cutesy wrapper.
Just basically how the Explorer actually shows you the file at the end of the day. If you move it, you're actually changing it to another node in the file structure, whereas if you're renaming it, you actually remove it and then put it back in the same place.
Yeah, that's right.
Different names.
Just like directories have directory info, files also have file info, and so that's where I can also interact with whether or not it has an archive bit, whether or not it has a hidden bit, and go on from there.
Whether it's encrypted.
And whether or not it is encrypted. Yeah, I mean, no doubt if we were to look at the implementation of
almost
encrypt,
as if this all hangs together.
Yeah, these are very related. What if these teams talk?
Could well happen.
You know they do. All right, let's take a look at the implementation itself. So here's a nice iteration of all the files in a directory. So I get dir, that's just the path to wherever the directory is. I can use system.io.directory.get files, and just like you said, I could use a using that would make it a little easier syntax, so I don't have to put the system.io. And then I can just iterate through those. And in this case, I can use the path object again, this time not to combine, but to correctly extract the file name. Boy, how valuable that is. And instead of, what would you do? You'd have to find the last slash, and and then after that, and it's just a pain, right? All that logic is wrapped up inside path. Here's the rename operation, right? And so I can say system.io.file.move, and I give the before name and the after name, and now it's done. Pretty nice.
Yep.
And then we were talking about file info. In this case, I'm getting the length, in this case, or the size of the file. It comes back as bytes, so I just go a quick divide by 1,000. It tells me how many kilobytes there are.
That's awesome. And so you could see how you could easily build utilities that kind of measure disk space usage through these kind of things. You could crawl through all your files and say which are the big files that are occupying my file system and so on.
Yeah, you could write your own file explorer.
Yep.
I mean, anything that Windows can do, you can do.
Absolutely.
That's not totally true, but certainly a majority of the things that Windows can do, you can do against the file system too. There's a lot at your disposal and a lot of danger. I mean, you can shoot your foot, no doubt about it. You've got to be careful. All right. So that's the file system. Definitely a great way to persist data. Definitely a great way to read data. Give utility to your application insofar as the local machine. But then there is the data that's outside, right? We need to pull data in. I can talk to a system directly as long as I'm not worried across my network, as long as I'm not worried about firewalls, as long as I'm not worried about things getting in the way or reliability, right? I mean, that's important.
Yeah, absolutely.
Right? We've done remoting for a long time, and that's basically what that is. And but now we have web services, and web services have kind of solved many of these problems, not just about reliability, but also access and firewall problems.
Yeah, well, it's addressed a number of the initial problems. You mentioned, we used to have arbitrary services that used to be running on different TCP ports, used to be running on different IP addresses, and we're not all sitting at home without a firewall. These days, we're all working inside our corporate environments, we're connected through firewalls and so on and so forth. And so the industry has kind of settled on the idea of web protocols as being a great way to share information across all of those boundaries, because port 80 is generally open.
And it's turned out they were right. It is. It's a very good way to do it. All right. The benefit of web services is a lot like the benefit of object-oriented programming, to be honest. It allows us to take a lot of functionality that's on the server and encapsulate that away, right? And be able to expose these endpoints that often are just like methods, right? That you can call to, pass information to kind of change the variability of what's operated inside.
Facebook has a set of web-based APIs. We don't know how Facebook has implemented that, but we can interact with those APIs because they've encapsulated and packaged them up.
Squirrels, mostly squirrels. Right?
Wow, I'm glad I don't read your posts.
Yeah, it's crazy. Twitter is all, I mean, it's just hamsters jumping on keyboards.
Awesome.
It's the weirdest thing I've ever seen. I don't if you could see, it's just a warehouse full of hamsters.
Yeah.
It's
everyone's
they can
now
scale.
starting to understand what I mean when I say awesome.
They can really scale. All right. What were we talking about? All right, one of the things it really does, and this is probably back to service-based architecture, service-oriented architecture, is that web services allow me to expose my system to anybody. You could actually be running on an iOS device. You could be running on an Android device. You could be running on a Windows Phone. I don't really care. I'm exposing this as a standard that allows you to consume it and allows me to expose it. That's a lot of value.
A lot of value because you're not building multiple implementations for these different platforms.
Earlier, we were talking about sharing libraries. I mean, there were some limitations around sharing libraries. This really breaks some of those boundaries. It also introduces loose coupling. How would you define loose coupling?
I would say it was the opposite of non-loose coupling.
That's the way I would
my muse deserted me there.
No, seriously, a loose coupled system, well, a tightly coupled system is brittle. I mean, it's not necessarily brittle, but it kind of is.
Well, you've really hard-coded dependencies. You've turned around and said, this will not work without that, and you've really put them hand in hand and turn around and make them so dependent that touching one will break another.
Yeah, that's exactly right. And I can, thanks to web services and loosely coupling, one of the things I can do is change, let's say it is all hamsters and we know it's really not. Let's say I want to change it to all monkeys jumping on the keyboard. Nobody really cares as long as what I'm exposing is a reliable interface. That is completely loosely coupled. I could bring in any animal I wanted to implement my service. And the reality is, as long as I'm a reliable interface to the user or to the consumer, in this case it's an application, I'm loosely coupled. I can do whatever I need to. I can upgrade, I can downgrade, I can change implementation, change technologies, whatever it is I want to. And that's one of the best parts of web services being standard, is that I really could change technologies.
Okay.
Yeah.
Sounds awesome.
Yeah, it sounds like I've convinced you. All right, so let's talk for just a second about SOAP. I'm a big fan of SOAP, Darren. Big fan. All right, one of the benefits of SOAP, of course, is that it is also a standard, and probably the biggest benefit, it was one of the first really successful standards, allowing you to take payloads of structured data and put them into a format that you could pass around through standard web protocols, right? I could take it, it is just text in the end, it looks like XML, I'm passing along, it ends up being just an envelope with some pieces inside it, I pass that around, I know how to serialize it, which means to turn it into a string or turn it into XML in this case, and I can serialize it on the server, hand it to a client, and because it's a standard, they can deserialize it into some sort of object that they can use.
And there's a lot of value to SOAP in terms of the way that it describes its own format. You know, you have the WSDL web service description language that defines exactly how this web service is going to interact, exactly what format of data you're going to be passing to and from it, and so on. But there's some downsides to SOAP as well.
There are, no doubt the payload is heavy, right? The way that we actually serialize it is very voluminous, very big, no doubt about it. Yeah. And so as a result, there are other standards emerging that try and solve that problem, because as it turns out, you know, I think Facebook's probably an excellent example here, so is Twitter. You know, you might save, what, 400 bytes? Big deal, until you have 400 million calls. Now suddenly those 400 bytes really matter. Yeah. But back to the defense of SOAP though. What's great about it is the full support inside Visual Studio. I can point to a SOAP service, and Visual Studio will build all the local client proxies for me so that I can interact with it without even having to think about it as a service. I almost talk as if it's a local class, and I can access its methods, access its properties, access its types. Yeah. Very easy to use. I think probably inside an enterprise, and again, it depends on performance and probably scale. You know, it's still an excellent option. You know,
especially if what you're really considering is not only the performance of the service itself, but also developer productivity. You know, if you're building this in-house, you're not necessarily going to be exposing it out to a broader standards-based consumption. You can constrain within your enterprise exactly what devices are going to be interacting with it. Then, you know, why not use something where you have all the tooling, you have the ability, it's just going to generate everything for you.
Yeah, so here's a quick sample of the envelope and how it looks for a SOAP service. It's simple enough, right? And we're going to talk about some of the alternatives here. And probably a good alternative to start with, and the one that's next to the slide, is
as if we planned it.
It is weird. It's like it's how. All right, so the is REST, right? REST stands for
Representative State Transfer.
Golly. I'm so glad you're here. Never thought I'd say it. So
only for a moment.
At that moment. All right, so REST without a doubt is becoming the industry standard. This is the way to interact with a service. You don't
Some
have
might
to
say
have.
it is now.
It has already become the standard, yeah. If you look at major services on the programmable web, I mean, it is resoundingly REST. It doesn't mean you don't still see SOAP. Often you'll see dual implementation. Some systems really do prefer one over the other. REST is really nice. Some of the features of REST, of course, that it doesn't require XML parsing, right? Because it really puts everything on the URL string in a lot of cases. And it doesn't require a large header that SOAP requires.
So that's kind of inbound you're talking about there, that you can specify on the URL, this is the resource that I'm after, and this is some additional information about it that I may want.
Yeah, and what's great about it is because it's in the URL, you know, people can see it. Or
URI, I guess.
Or URI, people can see it. And one of the things about REST is it's human readable. And now, not always, but often it's human readable, which means I can look at the URI and kind of make out what I'm getting. It is my service / invoices / customer / whatever, right? And I can kind of go from there and kind of, it all kind of makes sense. It's not all bundled together in some cryptic format.
I remember what it was that we needed to do. Install the JSON viewer for Internet Explorer.
Ah, yeah, remember that? What's it matter now? All right.
Indeed.
We only have Internet Explorer installed. Doesn't matter. All right, so one thing that's nice about REST, of course it uses less bandwidth because you're passing so much less to it, right, in order to retrieve it. But typically what they return back is not this SOAP standard, not a serialized set of objects inside this envelope, but instead a simpler format, like just a simpler version of XML. That's very common to return, but probably most common isn't XML to be returned, but it's JSON to be returned. What does JSON stand for?
JavaScript Object Notation.
JavaScript Object Notation. Yeah, that's right. Well done. I was wrong again. All right, so let's see. So JSON is without a doubt one of the most prolific standards now. I mean, people just love it. It's easy to interact with. Has some gotchas to it. It's not all golden, but at the same time, it really is great. Very, very light payload. Very light payload comparatively, right? That's the reason people love it. Let's look at just a basic implementation using a web client. The web client is a wrapper around the HTTP client, and the reason it exists is because it handles common operations for me. It's really nice. Anyway, so we're going to use the web client because it's the easiest. So we'll create our first URL, and that's going to localhost 1, it's just going to a service, right, that returns JSON. Once I do that, it returns back as string. I don't get back JSON. I mean, it is JSON, but it's not a thing. It's just a string. And so then we can see in the middle block there where we start to deserialize it that we get a JavaScript serializer as part of the framework. There are a couple serializers to interact with JSON, and then we just call for it to deserialize, and when it does, instead of the string, it truly becomes objects at that time. And now instead of parsing the string, interacting with the string, or mess, now we really are dealing with objects in a type-safe way like we would expect in the first place.
That's awesome.
It's very nice. It really is. And then we can use those. That's all the bottom is really showing is how we use that.
So is that data an anonymous type there?
That data?
That data.
No.
Their data.
That data is not an anonymous type. And let me just make sure I know what you're talking about. You're talking about the data that's returned from deserializer, right?
Correct.
Yeah, absolutely not an anonymous type. In fact, this is a generic method, and so we're passing in that it's JSON sample.data. That is the strong type that it is going to be when it comes back.
So that's awesome because we can share that across our application. It's not just scoped to where we're interacting with it right now.
You're right, it's not. And even better than that, of course, this is not defensive programming either. It's not a guarantee I can deserialize that JSON. There could be a typo on the server, and I need to be a little more careful, but this is certainly the vanilla implementation.
Perfect.
I'm going to pull up Visual Studio for a second. I want to kind of show off in general.
Sounds good. I mean, one of the things we should point out in that the code snippet we just had there was you might have looked at the URI and been concerned that you see .svc partway through the URI. If I bring that back up whilst setting up. And that's just because we used a very simple implementation of a service. There are many other technologies in the Microsoft stack that we could have used, such as Web API, that would have got rid of that extension on that service and made it much more in line with what we're talking about with REST-based services.
That's right. So let's see. I'm trying to think of the best way to access that JSON that's coming back. I really don't know. I mean, without taking the time to actually go through the. It's okay. It doesn't matter. If you want to see what JSON looks like, it looks like a bunch of squirrely brackets and items in quotes. I mean, that's what it is. It certainly doesn't look like XML.
Or you could debug and actually have a look at it.
Oh, you know what? That's great. I'll do that. Thank you.
You're welcome.
Idiot. So let's see. I am in Visual Studio. Why wouldn't I just use Visual Studio to do it?
I have no idea.
Excellent idea. Absolutely excellent. All right. Right.
So let's show his Visual Studio.
Yeah, show mine, and I will actually let me. There we are. And let me copy the URL here. But let me first show how this URL. It really is an interesting way to interact with the service, where I can say service slash, like you were showing before. It doesn't have to be SVC. That's because I'm using WCF. Like a slash, and then I can, from that point forward, start to pass logical pieces to it that hopefully make sense to me. If you look at the code implementation, what I'm actually expecting is slash JSON and then a number, and then we're going to get multiples of that number.
Awesome.
And so I'll just say slash JSON slash 5. Right? I'm going to copy it for a second, and when I run it, it will. Oh, that actually would be just fine. That would.
Now you need to save as. And
no, I'm good.
There we go.
All right. So this is JSON notation. This is easier than anything, and. What happened? What it's doing is, so this is the notation for an array, right? Brings it back as an array, and which is inside this type, what I'm actually getting back. In this case, it has two properties, one of multiples, which is of type array, and one of number, which is an integer whose return is 0 in this case. Interesting.
Interesting.
Yeah, all right. So that's just what it looks like. Let's look at how we might consume it, and I'll go into. And I don't want to show the service, so I'm gonna close out the service here. Just know that there is a service. It's a REST service that returns multiples. I want to be able to interact with it and kind of show off how the serializer works. If I were to show you here, it would basically use that sample that we looked at in the slide. Again, I'm going to use web client, and the purpose of using web client is just because it wraps all the simplicity around it. So I'm going to go ahead and do like you said. I'm going to go ahead and put a breakpoint here. I want to make an interesting point about breakpoints. This is probably another one of those underutilized developer features, and that is I could have breakpoints everywhere. Right? Just like kind of like this, right? Just everywhere, and that becomes really burdensome. I'm constantly having to continue, but I might actually need a breakpoint there in a certain case. And so what I can do is I can create a conditional breakpoint.
So did you right-click on that breakpoint there?
So I go to the breakpoint, which all I do is click in the margin to get that. I could hit F9 as well in order to make a breakpoint come and go. And yeah, so I right-click a breakpoint. It gives me this special menu, the little context menu, where I can select what the condition is. It's pretty powerful because when I go in there, all I have to do is create a small predicate that indicates when that breakpoint should fire. So, you know, if it has to be when value equals true. Now when value is true, or whatever value might be, right, that is going to return whatever the true or false is, the breakpoint will fire. And that allows me to have breakpoints in strategic places throughout my project that do actually fire and raise whenever I need them. It's really nice.
It is. I mean, another great scenario for that is when you have a loop. And you may have a problem that, you know, after 3,000 times running through the loop, you run into a problem. Nobody wants to sit there and hand debug through the first 2,999 iterations because that gets old fast. So instead you would put a conditional breakpoint in there that would break once you hit that scenario.
Yeah, it's really great. It's just another little piece of developer candy that's kind of in Visual Studio. Excuse me. Okay, so I'm going to go ahead and debug this so we can kind of take a look. I will debug right here, though. Actually, let me debug one line up. It's nice we're using the async syntax. We'll talk about that a little bit later. We're certainly not going to skip over that, but that's the reason await is there. So let me set this to be the startup project and go ahead and debug it.
Just time.
Oh. Nice. All right. So it ran. Of course, you can see it's blank here, right? Everything's good to go. And I'm about to step into it. Now, before we do, I want to make sure you see the whole context of this application. That's the whole. There's very little code.
Yeah. We'll pause whilst everybody reads that.
All right. So there is a lot about to go down, but I want to kind of show that off. First of all, this is going to be showing off the JavaScript serializer. That's in the web script namespace, and you may or may not want to include that in your project. And we'll talk about that, and that's one of the reasons you may choose other serializers. Also, I'll dial on down to show that when I do receive back that JSON, what I want to do is I want to cast it into a type. And so this is for the JSON sample right here, and this is the type I'm going to cast it into. The deserializer understands that as long as all of the properties are named the same and all of the types are properly set, it knows how to go ahead and serialize it back into the objects that you want. And so take a look. Here I am in the first one, and we'll do 3 iterations of this. So I'll say F10, and as soon as I do, this is the JSON that was returned, right? There we are. Simple enough. And when I do, now I spin up the serializer, and it's with the serializer that I'll deserialize. At the same time, I might say, it's with the serializer that I would serialize it as well, right? It goes both ways, just like the encryption tools can encrypt and decrypt. All right, so now the serializer is ready. I've passed in the type that it's going to be deserialized to, and here's the string that it's going to receive. I'll say go, and as soon as I do, data goes from null now to a strong type, and it has all of the multiples already set the way you would want them to be. Pretty nice.
That's great.
Pretty nice. And now from
this point,
saves
you a lot of code manipulating that string.
Yeah, so now from this, yeah, no doubt, and errors and everything else. I mean, regular expressions are powerful, but that kind of string manipulation is brutal. All right, great. So now I can, from that point forward, I use it just as if it's a regular object. Very, very nice. All right, so now let's look at the second scenario. The second scenario is using data contract JSON serializer. The main reason you might want to use this is because it's in a namespace that you are willing to include in your project. There are times when you don't want web.script in your project. That's not unreasonable. And you might also find the use of data contracts very valuable, so that if you have if you do have a property and it just doesn't match the strong type or the defined type, then you can use data contracts to decorate. Earlier we were talking about decoration. You can decorate your classes, and so let me kind of dive down to show that.
The key powers of WCF is the ability to automatically generate different data types of endpoint, and so by using this data contract and data member, you can have a common type that is then exposed out as a SOAP endpoint, as a REST-based endpoint, and so on and so forth. And so you've got that common nomenclature that you can use across them.
That's right. And so data contracts are special. Right? A data contract is basically saying, I guarantee that it will look like this. Right? That's very nice. It's a lot like an interface when we went back to strong types. And so if I were to go down and show you the layout for that, so see how nice and simple it is for JSON, right? But at the same time, there's a certain level of brittleness there that you never know if everything's going to be laid out, if number is going to always be 0, things like that. And so here's here's the same thing, but using a data contract. And here I get to decorate it with the fact, first of all, that the class is the data contract. And here I've made them all match, but I don't really have to. I can go in here and set specifically that the name is different, that and the name is specifically Bob, even though I'm putting it into a number property. That allows me to have my strong type look the way I want it to, regardless of how it might actually be.
So what it looks like is that the data contract serializer is actually using reflection to go and find these attributes that are placed on these various members, and then it can look up and see those attribute properties such as name, and it can actually map a different incoming name to this property.
That's right. How would it ever know about these attributes if it didn't reflect into it? That's exactly right. Under the scenes, so much of the framework does use attributes. I mean, does use reflection, absolutely.
That's right.
And attributes too, but certainly reflection was what I was going to say. All right, great. So here's a little bit different. I'm using a data contract this time, so I have to set up my receiving type with data contract, and set up all the different members as they are, make sure the types are correct as well. I can also manipulate types as they come in as well. There's a lot of power that I can really go through. All right, let me go back to the scenario and kind of walk into it. Just as before, I'm going to use web client to go get that JSON. Here's the resulting JSON. This time it's a stream, and I can say to the serializer, which is expecting a stream, I can say, it's at instantiation that I tell it what it's going to be deserializing in this case, right? Just slightly different syntax. So I'm going to pass in, the type is going to be data contract.data. That was the one.
Wouldn't it be great if that was a generic?
Yeah. So it's not.
But
hint.
But it's one of those things that has been around for quite some time.
Yeah, exactly. I'm actually a little bit surprised that it's not. In fact, now I'm curious. No, it's not. All right. Okay, so here we are. I have the serializer. The serializer now understands what it's about to deserialize.
Before you jump in, the service is actually part of the solution that you've downloaded, so you can actually run that at the bottom of the solution and interact with it just exactly as we're showing right now.
Yeah, it's called Simple REST Service, and it's just sitting there, waiting to be run. Right here. That's right. If it's not working, it might be just because you need to spin it up. Just right-click the service, and you can say open in web browser somewhere. Oh, it doesn't show up while you're debugging, but you can select open in web browser, which would show up for you if you're not debugging. That will cause the service to spin up in case it's not. Yeah.
Perfect.
Yeah, and okay, so back to the serializer. So now the serializer is ready. I'm ready to deserialize my JSON into an actual object. That's in the read object method. Read object then comes back as an object, not good enough for me, so I'll do a quick as and make it specific what it comes back to.
And because you're constraining this environment, that's perfectly safe for you. But obviously, if you were building this in the real world, you want to put some guards around that.
I would indeed. Not only would I want to make sure that this didn't return an exception, but I want to make sure it didn't return a null.
Perfect.
Yeah, well done. All right, so this is the second JSON serializer, and really the only other JSON serializer in the framework. And it depends on the namespaces that you're in. If you are writing a web service, odds are you will already have web.service, web.script in your already referenced. But if you don't and you're writing a client application, you might be using the data contract serializer.
And of course,
instead.
we do have the client profile for .NET that does include some of these server-side assemblies, different variations of the .NET framework install.
Yeah, that's right. Now that would be only for .NET 4.5. .NET 5. What current version of .NET are we at?
It's 4.5 right now.
Yeah, so that would be for .NET 4. 4.5 we got rid of the client, but it is a big source of confusion for developers, especially back on 4, where they suddenly are using they have a reference by default as the client, and they're wondering why things aren't working the way that they're supposed to, and it's because they have the abbreviated client framework. Yeah, exactly. That's one of the reasons we got rid of it as well. And some refactoring, some rework of the existing framework actually saved so much space that really the gain was quite trivial. You know, in size. That was the reason client was originally created. Okay, now once again, data is strongly typed. I get to see everything like I would want to. That's nice.
Yep.
Here we go again. This is exactly the same as before. And then I'll come down, and now we'll do it. What if it returned XML? So if we were to look at the service is nice. It's really simple. All we have to do is add this web get into our methods. And as soon as we do, that says we know that we're going to be using REST to access it.
So that's another attribute that's being applied to it, so that the WCF environment now knows to start changing how this is being dealt with.
Yeah, that's exactly right, and it's actually a very neat way of notating something without having to go in and spin things up or put them in new files. Or yeah, that's a great way to be able to change the behavior of something and still keep the same syntax that you had before, because I didn't have to then change anything that I did inside the method. So in this case, if my URL says /JSON, I know that I'll be returning JSON. And I partly know that because even in that same web get, I say what the format's going to be that's returned, and it does it all for me. I don't have to worry about the serializer behind the scenes. I know that it does it. And then at this one down here is exactly the same, except for it has a different name, of course. And it returns XML. But from the user's point of view, they don't have to know the name of this method. They just know, because REST is very easy to use, right? We wouldn't try and expose everything for encapsulation's sake. We can say /XML/ and then it's whatever the name of the parameter is. Of course, we could have multiple parameters here as well. It's very nice. All right. This is the service, and this time we'll be calling XML to return it, and we'll be using the XML serializer. So this is the third and final scenario, so that we can kind of look at what's returned. All right. So here we go. Same as before, I'm using the web client. And now I'll be returning, once again, a string. This is the XML. In fact, let me close this. This is another neat thing. I can sniff what the value of variables are while I'm debugging, but I can also view them different ways. I could see it as text, as I just did, but I know this is XML, so I could use a visualizer so I can see the data the way I need to see it. Very, very nice. This is looking at it as XML. You can see what it's coming to me as, and what the serializer is going to receive. So when it deserializes it. All right, so here we go, and here's the. And so you can see there's a little bit more because I use a memory stream. Oh God. No, that's 8.
That's what I've been telling you the time.
All right. Nonetheless, just as before, it takes in the data and returns strongly typed. So now, regardless of how you want to do it, JSON, XML, SOAP, we can use strong types on our client and interact with any of the standards that the services may have implemented. All right. Transitioning on to probably one of the most important topics, and
that will incorporate into the next module.
That we'll have to split because we just can't do this one too much injustice, right?
Yeah.
And it's the introduction of async and await, the core keywords to allow us to do asynchronous programming in .NET. We didn't need them to do asynchronous programming before, but let's look at it at least quickly.
We'll do it in the next module.
Well, let's look at least the fact that there are in async. Let's see. There we are. Asynchronous programming. This will give some homework over the next break.
10 minutes.
Yeah, they can kind of take a look. And asynchronous programming, generally speaking, is the ability to release, right? If you do things synchronously, it means everybody waits for you to finish. But that's not what you want to happen. What you want is for you to be able to do something and nobody has to wait for you. And then once the operation is completed, you can return. That's really the fundamental differences between synchronous and asynchronous. And we would, of course, say it does maximize all the resources that you have. If you don't do it asynchronously, your resources become very constrained. And so asynchronous allows you to spread things out. You can also use, of course, parallel libraries for the same sort of tasks. It also frees up the system. So from a UI point of view, especially a UI point of view, you can do some long-running task and not have to wait for it and not freeze up your application at the same time. That's sort of, that's a very good user experience as well. You don't want to make it so that when they click the button, the 5 seconds that it takes for the operation to complete, the button is frozen in place and you don't see any kind of operation. The user can shake your application and all it gets is the not responding dialog. Asynchronous development allows us to have long-running applications not affect our apps. So that's the beginning of it. Of course, we're going to implement that with the await and async. You can go to msdn.com and search for await and async, do a little pre-reading, and we'll hit those at the beginning of the next session. And for now, we'll take a quick break. This is going to be a 10-minute break, and we'll go back to our final module. That'll be Module 8, and we'll see you soon over there.